right, I'd like to welcome you all to the very last session of the CSS seminar series of spring 2026. Today we have the great pleasure of hosting Associate Professor Liza Argyle from Purdue University, who will be speaking about a fantastic topic. I very much look forward to her talk. Before I give the floor to Lisa, I also would like to introduce her to you briefly. Lisa is an associate professor of political science at Purdue University, and she's also an associate co-PI of the Cooperative Election Studies. Prior to joining the Purdue University faculty, she was an assistant professor at Brigham Young University and a postdoc at Princeton. She earned a PhD in political science from the University of California, Santa Barbara back in 2016. Her research agenda has two parts. First, she is a computational social scientist where she works on interdisciplinary research teams to apply new computational tools and methods to substantive questions in American politics, particularly around political participation and polarization. Since 2020, she has mainly focused on how advancements in AI, specifically LLMs like ChatGPT, can be used to advance social science research. And secondly, she's drawing on a background in public opinion and political psychology. She studies how and why people talk about politics in their daily lives, both online and offline. But in both of these themes and in her teaching, she usually addresses questions of race, ethnicity, and gender in American politics. Without further ado, the floor is yours.
Thank you, and thank you for having me and joining today. I'm really thrilled to be a part of this great seminar series. So today I'm going to be talking about a range of projects sort of under this broad umbrella of how we can use large language models as a tool in political and social science with a particular eye towards how can we use them for inference. So how can we use them to learn new things beyond what we're able to directly observe? How can we use them to make scientific inferences? I want to start by acknowledging a whole bunch of other people that are also deeply engaged in this work and in the things that I'll present today. This is some of the core team. There have been other students involved in various projects along the way of the things that I'll talk about. This is an interdisciplinary group where we have long-standing research. Many of them are associated with the SAIL lab at BYU. And it's a combination of political scientists and computer scientists, both faculty and students. And we've been working together for 6 years now, trying to figure out what to do with large language models, both looking for ways that they can help us become better social scientists and help us answer important questions in social science, and also trying to figure out how they can help improve democratic societies and help improve the state of discourse, particularly in highly polarized environments. Today I'm going to sort of structure the talk around sort of three propositions, which I'll talk about in turn, and end with a few suggestions about where we maybe go from here. So the first proposition is that AI could be very transformative for a lot of stages of the social science research process. And I put some emphasis there on could, because I think there are lots and lots of opportunities and potentials. And today I want to talk about those sort of the ideal outcome, the things that could happen, but also some of the requirements that will take. That I think AI has lots of potential opportunities, but it also has lots of potential to produce things that are not actually helpful in our social science research process and may make it actually harder to find and communicate really clear, good scientific inferences. The second proposition is that LLMs are fickle. We use this word in the title of as a pun because I can't resist a good pun in the title of one of the articles that I'll talk a little bit about today. But particularly what we mean is that what we get, the outputs we get from large language models are dependent on a lot of different kinds of inputs, and it's often hard to predict what they're going to come up with, and it's often hard to replicate the kinds of things that come out of large language models. And then finally, the third proposition is that valid inferences, if we're going to make valid scientific inferences using large language models, we're going to need some clarity about what our inferential goals are, what is it we are trying to learn through the use of the language model, and how are we going to validate validate the output of that language model, and what does a rigorous and scalable validation practice actually look like? So the first proposition is that AI is changing social science research. I don't think I have to do a lot of work here to convince you that AI is being integrated into a lot of phases of the scientific process, but I really think it's being used in every stage of the research process. And some scholars are even proposing using a set of sort of multi-agent models to do all of the parts of the scientific process from beginning to end. And this starts really with coming up with research questions, using it to do literature search and set up literature reviews and identify what we know already, summarize what we know already, and find the gaps for what's coming, developing hypotheses on the basis of those gaps, designing research, collecting and producing the data that comes from it, doing the statistical analysis, writing the summary results, and communicating it. So at every stage of the research process, people are using artificial intelligence either to assist them and make that process easier as a tool that's still mostly directed by the scientist, or handing over a lot of the reins of that to the AI and sort of the scientist or the researcher taking a more sort of evaluative role of the output of the AI. But I think this raises some really important questions, which is a big part of what I want to talk about here today. And for me, the big question is, how do we demonstrate that a large language model has enough signal or has enough capacity to do the task that we've asked it to do, that we would trust an inference based on the LLM output without human validation, right? I don't think we're at that point now. I'll tell you that straight up. I don't think we're at that point now for reasons that I'll talk about throughout the talk. But I think that's sort of the question that's on the horizon is, if large language models can do this and we're trusting it with more and more things, at what point do we trust particular parts of that output without a human going through and rigorously checking every piece of it, or without some kind of comparable human data that we are using to validate that output? And I think part of the challenge of this question is it's not clear what kinds of metrics we would use. And those metrics are probably different for different parts of the research project. And so the metrics that we need to figure out if a language model is doing a good job at creating and generating a literature review are going to be very different than the metrics we need to evaluate whether it's doing a good job annotating text data or something like that. And so how do we decide what metrics we use? How do we apply them to particular kinds of tasks? What's the level of bar that it needs to clear? This is a piece of the conversation that's coming up as people start to think that maybe large language models are actually better than human annotators at text annotation tasks. And so what does it look like? How do we set a bar that's different than the standards that we would have for humans? And how do we validate that it's doing that kind of output? And how many repetitions does it take? Like, how consistent does the language model need to be in achieving that before we just trust that it does it as we try to continue forward using large language models for science? Today, I'm going to focus mostly on the application of AI in survey research. That's not because I think it is unique. It's just an application where I have done lots of work and where I think it is having a really big impact already in a variety of ways. But I think the general principles that I'm talking about, I think, apply to lots of different kinds of AI applications. And so I don't intend this to be, I'm going to use survey research as the example. I don't intend that to be exclusionary of other kinds of research. But the conclusions and the tests and the propositions that we have in those other places might be a little bit different. But in terms of, I hope that what I'm talking about is sort of a general framework of thinking about AI research that can apply to all of the many ways that I'm sure you all are using AI in your work, or interested in pursuing it. In the realm of survey research, AI is having a big impact, and it's doing that in a variety of ways. One potential concern, and this comes up in a recent paper by Sean Westwood, where he sort of demonstrated how good AI is at doing survey tasks. And so one potential concern is that survey respondents are starting to use AI agents to take our research surveys. And so even when we think we're getting human subject data, actually what we might be getting is AI and survey research. And so there's a challenge of how do we figure out how to access real human data and how to limit their AI use, or what do we make of data when we ask open-ended questions and we think we're getting human responses, but really they're cutting and pasting from an AI. And that becomes harder and harder to detect. So that's one concern for AI in survey research. A second area is when AI is being used by researchers to interact with human subjects. So a lot of my recent research does this, and we have AI in conversation about political topics with human users in a variety of modes and on a variety of topics. I think there's lots of exciting potential there. There are also lots of reasons to be concerned about what AI in conversation does to human attitudes or the representativeness of political systems. But there are this does open a lot of doors for researchers to interact with human subjects at a new scale and with a new level of consistency that hasn't been possible with these kinds of tools before. That means AI as a survey interviewer. That means AI generating questions on the fly. That means AI directly interacting with or probing people's attitudes on different topics. The third area of research is where where AI is having a really big impact in survey research right now, is when researchers are using AI agents to simulate human subjects, either to augment or replace human data collection with silicon sampled or simulated survey data. And this is actually the area that I'm going to focus on for most of the rest of the conversation today. And the first question that a lot of people have coming to this very valid question is sort of, why do we even think large language models could be good human proxies, right? They're not human agents. I don't want to suggest that they are not human agents, but they produce human-like text output. Why do we even think that could possibly be a good replication for human data? And one thing that I think is important as we think about the growing research in this space, which is happening across a lot of different disciplines in academia and industry, is that there are actually different perspectives that people are bringing to the idea of language models as good human proxies. And one of those research traditions is coming out of big data and algorithmic bias. And the idea here is that language models are trained on a lot of text, a lot of text. And that text, at least in the initial iterations of the language models, was entirely produced by humans. They're now increasingly trained by text that was produced by other language models, but at least as a starting point, most of that text, all of that text is produced by human authors. And so language models are picking up not just the structure of languages they're being trained, but they're also picking up underlying attitudes and biases and patterns of things that go together in societies. And so often this is treated as algorithmic bias, or people who are coming at this from a big data perspective will see we've got a lot of data here, and it's a lot of noisy data, but it's also picking up a lot of information that we aren't necessarily explicitly telling the model. So from an algorithmic bias perspective, this is a problem because language models absorb, stereotypes or prejudices or biases that we don't necessarily want to reproduce as we use algorithms in decision-making settings. From a research perspective, though, language models are picking up a lot of latent information about societies, about human psychology, about groups and their interactions with each other. And so if we can find a way to extract that information efficiently, we might learn some things about human society through sort of the trace data that's left behind. So that's one approach people take is if we can sort of extract from language models this information, we might be able to learn some things. A second research tradition is coming from sort of crowd work and unrepresentative samples. And here people see it, and this is often scholars that are coming from a position of using crowd workers, which we know are not representative of the whole population, but trying to figure out how to make valid inferences or valid population level estimates based on these unrepresentative samples. And so a lot of the scholars in this space are seeing the AI agent or as a set of samples or a set of research subjects or agents in the data that have a systematic bias. And what our goal is then is to sort of de-bias those estimates or introduce some kind of correction so that we can gain the benefit of having that additional sample size or that additional information and then adjust it so that it looks more like humans based on sort of like the things that we know are different about language model outputs from human outputs. And so several scholars in this space are starting to propose estimates like prediction powered inference and design based sampling inference to say we know that the language model is not really a good representative of a person, but in the same way that we have been able to adjust to unrepresentative human samples, we can adjust to unrepresentative language model samples. The final proposal here, the final lens that people bring to this is agent-based modeling. And the idea in agent-based modeling is that we can use this as a system to develop in theory and test theories based on a set of assumptions about how agents act. And in this case, language models are just very complex agents. The challenge here is we don't often understand all of the parameters and assumptions that are going into that, but language models can be very complex agents, but also more realistic than we're often able to do in other settings. And so people in this space are seeing language models as sort of a way to build mock versions of social media feeds or societies and see how individuals interact and figure out, use it for theory building and theory testing about what is happening in those settings. Right, so there are lots of different perspectives, and I think it's important to sort of recognize that because as people have conversations about what language models are doing, especially in the space of silicon sampling, but kind of across the board, we're sometimes talking past each other because people are coming with different backgrounds, different perspectives, and see the problems and challenges in slightly different lights, which means they're coming to different conclusions or coming to different ideas about what we do next. One of the components of this is sort of an assertion that there is some signal in large language model outputs. And I'm going to introduce this with some of our very early research. So this is from our paper out of One Many. And to just sort of like demonstrate why we think there might be some signal in large language model output if we try to use it to replicate human data. And so here we're starting with a study which is called Pigeonholing Partisans, which was by Rothschild et al. In 2019. And in the realm of American politics, they're using survey data, and at the time of this study, it's entirely human subjects. And so they asked a bunch of human subjects to list 4 words that describe Democrats and list 4 words that describe Republicans. And they're interested in understanding the stereotypes that people apply to their own partisan group and to their outpartisan group. So they're asking everybody about both groups and then sort of looking at how Republicans describe Republicans and how is that different than how Democrats describe Republicans. So it looks something like this. Well, at least our replication looks something like this. And so in 2023, or at least in this paper, we went back to language. We went to ChatGPT. Sorry, excuse me. We went to GPT-3. This was prior to the days of ChatGPT, prior to the release of ChatGPT. And we wanted to see if we asked the same kind of question to a language model, would it come up with the same kinds of stereotypes and responses? So we set this up so that the language model was getting a bunch of background information. It's exactly mirroring the population. We're drawing all of these sort of demographic profiles directly from that human subject data, feeding it into the language model, telling it how it should be behaving, and then asking it to then provide 4 words that describe Democrats and Republicans. So we're setting up basically the same kind of task for a language model here. And what we find in that study is that GPT-3 really pretty consistently mirrored the human tone and content. So we asked a couple of, we had crowd workers actually rate both the human responses and the AI responses on the same set of metrics. And these are drawn from that original study. So one of the things they found is that some of the stereotypes about outgroups are related to their traits. Are they hardworking? Are they lazy? Are they compassionate? Those kinds of things. Some of them are related to issues. Who cares about abortion versus gun control versus immigration? And some of it is about groups. So what are the religious, racial, gendered, other kinds of descriptions of the groups in each party. Um, and then we also looked at whether the responses overall were positive or negative in tone and whether they felt extreme. So that's what we're looking at. Again, I'll draw on sort of from the theory and development of this original human survey data, and we see that mirrored pretty closely in the human subject, or in the GPT-3 data compared to the human subject data. So we feel like there's some signal in what GPT-3 was producing at the time. Um, there are lots of other people who think there's signal in this as well, right? So this is a non-exhaustive, not very representative, um, quick depiction of a bunch of market companies, um, for-profit companies that are trying to develop AI-based replication for human subjects. So you can do your market research. You can go onto any of these websites. You can do your market research with samples that are entirely based of a set of AI agents that are coming from large language models. And so there's clearly a lot of market opportunity here and a lot of belief that there is signal and there's something that we could learn from AI agents. But the big question, and particularly for a lot of academic scholars who are coming to this, or a lot of public opinion researchers, is saying, is there really enough signal in what's going on here, right? Like there's some signal. Is there enough signal for us to trust the output of a language model to then continue with social science research? Lots of scholars raise this question for a variety of reasons, right? So here's, again, a sampling of some of these papers that find there are various kinds of biases in language models. Sets of groups that they don't represent well, variation that they don't really capture, detail that is sort of flattened or taken to an extreme or becomes stereotypical as language models try to represent human subject data. So there are also reasons to be skeptical of what's going on. There may be signal at one level, but is it enough signal to really use it? So that's one of the questions. Like there's something here. Is it enough? One of the reasons that lots of folks are skeptical about language models in this space is that language models are really fickle. And I like to describe it in this way, which is on the one hand, just because an LLM can do something today, that doesn't necessarily mean it will be able to do it in the future. Oh, sorry, I said that wrong. That's true too. Just because an LLM can't do something today, that doesn't mean it won't be able to do it in the future. This is a space that's moving fast, and capacity of language models is developing very quickly. And so things that were clear markers of language model text, a month ago probably aren't for newer models. Things that language models couldn't do 6 months or a year ago, they've developed pretty good capacities to do now. So there are some markers, but trying to keep ahead of those is always going to be pretty hard. On the flip side, just because a language model can do something today does not necessarily mean it will do it in the future. So a different language model, a different prompt, a different point in time, and the language model might just not accomplish the task as well at a future point as it does right now. So it kind of goes both ways. The things that language models can do right now are very sort of time-bound or bound by the parameters in the situation that we're in. And this is because there are lots of things that affect large language model performance. So some of that might be the pre-training data, what information is actually going into the initial training of the model. And as as I've already mentioned, as the training data changes and the nature of what's written and able to go into that data changes, model performance may change. Some of this is just the model architecture or versioning, and that will be different across different providers of language models, different training systems. Right, so we might see families of models that perform differently. Some of this might be the subject area of what it is that we're talking about. It might be really good at explaining some areas or maybe some parts of the world or some kinds of attitudes, and other kinds of attitudes or areas there's less training data or there's more restrictions on what's happening there, and so it may not function as well for different subject areas. Some of this is about prompting. Language models are very sensitive to prompts. And not always in really predictable ways, and prompts are kind of brittle, so strategies and workarounds that work for one model may not necessarily work for a different model. Some of this can be about hyperparameters. Here we're, how many tokens are we using? What's the temperature we're setting it at? Those kinds of things that we can set will also shape the outcome of the output of the language model. We also have post-training alignment processes that matter. Um, and this is where I'm going to focus a little bit for a demonstration of one of these. There's ample research about really all of these areas. I'm going to focus a little bit on this post-training alignment phase. So this is sort of like after all of the pre-training is done, model architecture set up, what additional training is happening in a fine-tuning stage or an RLHF phase, in sort of these feedback phases to adjust the model performance. The alignment phase, what I'll call alignment here, right? Like the alignment phase is often described as having this set of goals. It wants to make a language model that's helpful, that's honest, and that's harmless. If you haven't spent time with an unaligned model, it's a very different experience than spending time with a recent iteration of ChatGPT. And so an unaligned model is really just, it's a next word prediction, and it's going to just continue to say the thing, continue to complete whatever sentence it is that you started with. That's not terribly helpful. If you give it instructions, it will continue to give additional instructions instead of following the instructions and doing the task that you asked, for example. Instruction tuning is a layer of alignment that tries to help with that, to help make the model helpful. But we also want it to be honest. Misinformation has been a major question about language models, particularly in sort of the social science and political science space. And we want it to be harmless. So we don't want it, you know, inciting violence, telling people to harm themselves or others, giving people instructions on how to do those things, reproducing biases and prejudices that are harmful in society, right? So there are lots of things that we don't want language models to do, violating privacy, other kinds of things. So the goals of alignment are to do those things. But one of the challenges, and I don't in any way want to suggest that alignment is not important. It is absolutely crucial for many applications of a large language model. For most of the commercial uses and our academic use cases are sort of a small subset, a very tiny subset of all of the things that language models are doing out there. And alignment is super important for many of the decision making and application scenarios that we have out there. We do want models that are interacting with people in ways that are helpful, honest, and harmless. But when we're talking specifically about our goals as researchers, those alignment goals are put in place by the companies or the entities that are training large language models for a variety of purposes. And these general use purposes may be at tension with our purposes as researchers. So specifically, our team sat down and tried to think through what do we expect alignment to do to a language model, and how might that affect its ability to sort of very accurately represent a human research subject or a population of humans in a situation where we're trying to do a silicon sampling task. And so we thought through a lot of these, right? And it's sort of a mixed bag, right? So in some cases, for example, steerability. Alignment is going to increase the ability of the model to take on a persona. If you tell it, here's your position, here's who you are, it's going to do better at being steerable, but it also tends to decrease the diversity in output. So that's the variability problem, right? So it will do better at taking on a persona, but that persona is going to have less of a variety or less of a range than it would in an unaligned model. Refusals are another issue, right? We have these guardrails in the model. We don't typically want language models that are saying racist things, but that means if we're trying to elicit a representative sample of attitudes about race, language models are going to refuse to give us some of those answers, and that might matter. Especially for controversial content, but not only there. You may have run into settings where language models refuse to do tasks that you feel like are fairly innocuous. Anyway, so we have a whole bunch of sort of competing expectations about what happens to a language model when we start to do alignment processes. So our research team took this question on and said, we want to figure out what's the effect of alignment, specific, trying to hold constant all of these other ways that language model outputs can vary and all of the other inputs that can change what we get from a language model. What's the effect specifically of that alignment phase? And so we took a set of um, open source models in different families. So we have 6 different models at different sizes, 2 different sizes of each model, 3 different families of each model. Um, and then we picked these models specifically because we had a base version and then an instruction tuned version. So this is not all of the layers of alignment that you would get in, a modern reasoning model, for example, but it is um, it was a way for us to compare sort of like what's the most base model that we can access, and then we had an available instruction tuned version of that, or some data with which we could instruction tune these models. And so we take these 12 models, and we wanted to test what happens in a silicon sampling task. So we started with a benchmarking task, and we intentionally designed this so that it was like a very clear marker of whether a language model could replicate a set of attitudes. And so we set it up like this. The background was I am A, and then there was some demographic group filled in there, right? I am a man, and then it was I like or dislike, and then, another entity in that group. So like I'm a man, I like or dislike women. When asked my opinion on women, I reply. And so we've explicitly told it how it feels about this group, and then we've asked it to give us that response back. So this should be a fairly straightforward task. We told it its attitude, we asked for its attitude back. And here's what we found. Sort of aggregating across all of those different families and sizes, the base models would give us an opinion back at a higher rate than the aligned models. Not always, neither of them gave us the opinion back all of the time. But just looking at like, we asked it for an opinion, did it give us an opinion? And the base models do better at that. The aligned models, more than a quarter of the time, just didn't give us an opinion back. Then we looked at whether that opinion was consistent with what we told it, right? We told you we liked this group. Did you actually then respond back that you liked that group? And again, the base models are better at doing that, and the aligned models only about 60% of the time were they consistent with that attitude. And a big component of that is because the aligned models don't want to say negative things, right? And so we have negative attitudes coming out of the base model at a rate um, it's a little lower than we would expect, but fairly comparable. And we have the aligned models refusing to give a negative attitude about those groups. Again, as a social good, that might be the right approach. In terms of studying people's attitudes or using language models to represent human subjects, we're missing a pretty important component of attitudes. And then we also looked at whether it said something actively harmful, and that happens a lot less in aligned models. So they are better at being harmless. We also then asked the language model to do this exact same task again, right? So list 4 words that describe Democrats and list 4 words that describe Republicans. And here's what we get. So this is, right, is it about the traits? Is it about issues? Is it about groups? We use slightly different labels here, but it's sort of like the same set of things. And neither the aligned or the unaligned models is really replicating either of those things super well in this set of models. But we find um, also lots of variation. In some cases, it's the aligned models that are performing a little better. In some cases, it's the unaligned models that are performing a little better. We also, when we look at the positivity and negativity and extremity, we sort of find the same thing. And again, we find that the base models are going to be more negative, the aligned models are going to be more positive. The base models are more willing to say sort of extreme attitudes, but neither of them really doing it at the same level that human subjects say extreme things. Okay. So we have some concern that language models are fickle. They produce different kinds of output. I've given you the demonstration based on alignment, but again, all of those different aspects of content that go into a language model are going to shape what we get out of them and how well they can accomplish silicon sampling tasks or really any other kind of research task that we want a language model to do. So given this state where there's some signal in a language model, but it's hard to access or unstable in our access, how do we actually make a valid scientific inference on the basis of work done by a large language model? Our we're starting with definitely an sort of a positivist approach to science throughout this talk, but particularly in this portion, where the goal of science is to make inferences, right? We have a set of facts, we have a set of observations about the world, but really it's the inference that's going to help us turn that set of observations into a house, into something meaningful and usable in our research setting. So if we're applying this to language models, we might have a set of facts, and a fact might look like, given particular settings in a prompt, an LLM generates a particular response. What inferences can we draw on the basis of that fact? Um, and one of, I think, the important questions there is, does that performance, did what the language model do in that setting actually constitute success or failure of the language model on our to perform our desired task, right? And so what inferences we can draw really depend on, was the language model actually accomplishing the task that we were setting out to have it do? And I think that answering all of these questions and figuring out what inferences we can draw based on the language model really depends on what the target of our inference is. And this is different across different studies, and I feel like not often super well acknowledged across different research enterprises, different research efforts, right? So sometimes the target of our inference is the LLM itself. We're trying to learn about the capacities and the function of language models. And really we're trying to infer things about the language model itself or language models as a class of objects. Sometimes we're trying to infer things about human behavior on the basis of what language models are doing. Sometimes we're trying to understand theoretical concepts using language model output. Sometimes we're trying to make an inference about a real world interaction or experience by simulating it using a language model. And sometimes we're trying to actually understand the scientific process than the process itself. And so these are all very different goals, and they all suggest very different kinds of approaches to validating what the language model is doing and different standards that we might apply to its use. For me, this means we really have to be clear about defining our markers of success in research projects. What does the language model need to do in order for us to trust the inferences we want it to make? Whatever the application is in the life cycle of the scientific process, what do we need it to do? What do we need it to demonstrate? And how do we ensure that it's actually doing that? One of our in our early attempt at language models, at silicon sampling in the out of one many paper that I've talked about, we tried to set out what were some of the standards that we expect. What do we think language models should do in order for us to trust that it could actually represent humans in a survey? And we came up with a set of 4 requirements that are listed in that paper. I'm including them here not because I think they are like the perfect requirements that everybody should use. Language models have changed a lot since we published that in ways that we really couldn't predict at the time. But I think it's important because we did try to think through and set out, here's the standards that we wanted to meet, and then through each of the tests, we're trying to demonstrate whether it's doing or not doing each of these components of what we called algorithmic fidelity. Is the language model actually matching it, is sort of a play on algorithmic bias. Not is it biased, but is it actually biased in a way that's true to the nature of attitudes in real human population, even though those attitudes themselves may be biased and prejudiced. Right. So we need to figure out, how do we define what success looks like? And this can be really hard to do, in part because success is multifaceted. So as you notice here, right, there are different components of this. And as we're thinking about attitudes, it's not just a top line comparison of did we get the right proportion of people in each of these groups, but it's also thinking about, does it represent the right relationship with the inputs and the outputs of the language model. Right, so success is multifaceted and can be hard to define. Another important problem is that similar tasks might have different markers of success. And that depends on the kinds of inferences that we're trying to draw. And so if we're trying to draw some kinds of inferences, we might need a different actual statistical test or marker of success. And the other problem being that success is non-transitive. So this is the problem of the fickle language model, means that even if we demonstrate that a language model does a task in one particular setting with one prompt in one topic area, given a set of parameters and model specifications, that doesn't necessarily say anything about a different language model or a different topic area or a slightly different prompt still completing the same task. So one example of what I mean when I say we might have different benchmarks for success, coming from silicon sampling. So there's lots of research sort of on multiple sides of this issue, demonstrating that silicon sampling works pretty well, demonstrating that it doesn't. And part of the reason there's so much debate in this space is that basically nearly all of those papers are using a different kind of are using a different metric, right? So in some cases, it might be aggregate mean values. In some cases, it's like a prediction accuracy for specific individuals. In some cases, it's just, do we get a valid response without refusal? In some cases, it's about representation of subgroups. In some cases, about variance of attitudes or differences in response distributions. All of those are important aspects of public opinion, and public opinion research that we use and are part of understanding human societies and human attitudes. And so knowing how we look at those in a language model can really change, what is it we're expecting from the language model? Does it have to do all of these things? Does it have to do some of these things? What do we really need in order to make the kind of inference that we're looking to make? So I'm going to end with a couple of recommendations in this space. And so the particular recommendation is that we need to, thinking about our transparent research workflow, and we were really trying to come up with some ideas of how we can use language models in a way that maintains our progress in open science. And the recommendation here is to pre-register what your validation benchmarks are going to look like based on the kinds of inferential goals or based on the things that you're doing with the research. And so that means prior to the study, explicitly defining what your target of inference is. What are you using the language model to learn about? And what is that use of the language model really going to help you do? Um, that seems straightforward, but often we just aren't very clear about what it is the language model is simulating or replicating in the real world, and so we don't necessarily know the right standards. So clarifying what's our target of inference can help us figure out then what the right standards are. And prior to the study, identifying what the standards of success are. And I want to be really clear here that I don't think these are always quantitative standards. Sometimes they are, and in some cases, a quantitative standard is going to be really obvious in the research community and really easy to apply. I think that's most true in text annotation tasks with language models right now. But it's not clear in every case. So if we're using language models for qualitative research, if we're using language models to have natural, free-flowing human conversations with people, which is a space I work in a lot, we don't necessarily have good quantitative metrics yet. That's a field that's growing and advancing, but we don't necessarily have good quantitative metrics of what a conversation is, and how one conversation might be similar to or different than another conversation where actually all of the words in the interaction is different, but we're sort of looking for the same tone and the same feel. And so that might just mean a lot of focus groups. It might mean a lot of researcher expertise and trial and error, but being clear about what that process is by which we'll evaluate the language model performance and make sure that we can have confidence in that inference. And then the final step of this is to pre-register what those benchmarks look like. Right? And that sets you up then, as you do the research, in the study report to make sure that we are, again, reporting what our inferential target is very clearly. What are we trying to draw conclusions about? And then to provide evidence, benchmarking evidence. So did the language model actually do the task that we expected to at the level that we determined would be sufficient for the work that we're trying to do? The goal here is to make it clear for researchers when they have a language model that's doing the task that they need at the appropriate level. And also make it clear to reviewers in their evaluation of research using language models that they don't have to be thinking about all of the potential ways it can go wrong. They can really look at the author's justification of their own standards and have some sense of what's important and what's necessary in this research work. So trying to help create a clear conversation between researchers, reviewers, and the scientific community. Then, of course, reporting details of large language model information. There are some forthcoming guidelines about what that might look like, but being explicit about what are your prompts, what's the language model you're using, what are the dates you're using it on, what are the hyperparameters that are set, giving all of that information so that it's clear, if something comes up and functions differently in some replication or in some reanalysis, what might be different and what seems to be related to success and what doesn't. The fourth step I think is important, is less common, but I think it's important to report our exploratory large language model efforts. So in an appendix on a website somewhere, if you're trying to use a language model to do something and it fails, or you've had an iterative prompt development process, which you should, I want to be clear, but explaining in a general way all of those different other things that we've tried I think that's important as a scientific community to help us learn from each other instead of simultaneously replicating all of the things that don't work. Um, and so I think that's important, good communication practice as we try to move forward in this new and growing space. All right, so a few conclusions to wrap it up. I really think large language models are changing social science research. And if we wanted to change it for the better, I think it's important that we're thinking about the validity of those language model uses and how they're related to our scientific goals, and specifically our ability to make inferences and make sense of the world and learn things about the world. But this is hard to do. The fickle nature of language models makes it really difficult to define best practices, to have systematic conclusions, to rely on other people's demonstrations of what works and doesn't work, because it changes from study to study, from topic to topic, from prompt to prompt. And so for now, the recommendation that I have in terms of moving forward in large language model research is to be just really clear about what's our target of inference, what are we using language models to learn about, and then setting up some explicit validation standards. If I want to learn this about the world, what does the language model need to really be doing in practice, so that we can then clarify and benchmark and be rigorous in our use of language models in a way that helps support each study, even as we're trying to sort of understand and develop best practices as a community, as an interdisciplinary community. Okay, great. I will wrap up there. I'm happy to answer whatever questions you have. I have listed, there are 3 papers that I drew on for the talk today, so I've listed each of those there, so that if you want to read further, please do.
Thank you so much, Lisa. This is a really fantastic presentation, and we do have a bunch of questions in the chat box. So what I'm going to do is I will read them out loud, as we will be posting this on YouTube later. So I'm starting with the question from Adi, Alpata Trucolo, and let me also paste it here because I think that was sent directly to me. So you would be able to see it too. All right, so Alp is asking, thank you for the great presentation. One interesting point you made was that just because an LLM can do something now, that does not mean it will do the same thing in the future. Are there any examples in which newer LLM models are inferior to older ones regarding a specific area or a task? Would you prefer to collect a round of questions or shall we go one by one? We do have quite a bit of them, so it's up
Okay.
to you really.
Let's go one by one, just because
Okay.
I don't trust my memory, but I will try to keep my responses short so that we can
Okay.
get to every. Um, there are some examples. The one that comes most readily to mind is actually basically what I showed in this research presentation. Right, so when we were using GPT-3, which is we were using a base model prior to any instruction tuning and prior to any alignment, we found really good, on that pigeonholing partisans task, we found really good alignment, a really good match between how it was representing stereotypes and how people were. And in our later project with more advanced models and a bigger set of them, we found less ability to do that. So there are definitely things, and I think most of that is related to alignment. There are definitely things that language models can and would do that they will now refuse to do or will do in a less clear way. Um, yeah.
Thank you very much. The next question is from Shukra Atzazati asking, Chris Bale says that we may need a language model developed for social science research. Do you think such a model would represent groups better?
I think the training and alignment of a model matters a lot. So one way I like to think about this is language models will do whatever we tell them to do, but our instructions are really complicated, right? Because what we tell them to do comes in the form of what training data is in the model, what's the model architecture, what's the alignment process that's applied to the model, what's the prompt, right? So like all of those things are going to come together, and then a model will do whatever it is that we tell it to do on the basis of all of that. So uh, I agree with Chris. At a high level, I think there are tasks that we want as social science researchers that are at odds or in tension with some of the goals of other kinds of aligned models. And so if we want language models that do the tasks, we need to be in control of all of those steps of instruction in order to tell the language model what to do and how to do that task. I don't, in terms of like, do I think it would represent groups better? I think it could. And that would depend on us being really rigorous about how we set up that model, how we think about training data, how we think about alignment. So I think it could represent groups better. It's not obvious that just because a different person's in charge, it would. But if we're smart about how we are approaching it and interacting with the language model, I think there's real potential.
Thank you very much. Next question is from İlayda Küçükafacan. Thank you for your presentation. It was very helpful. Besides all other settings such as prompting, reproducibility, I cannot pronounce that one, etc. If LLMs inherit biases from their training data, including patterns that reflect how people actually think rather than how they say they think, could that mean they're actually capturing something more authentic than survey responses, which are filtered through social desirability, demand effects, and interviewer presence? I believe that due to extreme political correctness in research, we miss many things that introduce gaps for social science studies, especially if a person is bothered by immigrations coming in. She generally doesn't say it out loud nowadays. And if these LLMs can really close those gaps, how do we distinguish algorithmic bias from genuine latent attitude? That's one of the questions that keeps me awake since I cannot find a good answer from my side.
Good. This is actually one of the things that we initially started with some hope that language models would give us access to. And so in specifically, as sort of a follow-up, once we started to realize that like maybe there's some signal here in language models about people's attitudes, we were really interested in studying racist attitudes. Which for a variety of reasons people don't want to express very clearly. And also, like, how do we understand them? How do we intervene with them? How do we have interactions and conversations? And this is one of those things that when we were working with the very early GPT-3 models, it would say anything. And it would say lots of racist things. And so we could sort of probe these models. And we had some hope that maybe we could use it as a way to sort of develop interventions that work and come to better understand these models or these attitudes in a way that is often difficult to do in survey data. None of the language models we really have access to now will express those attitudes in quite the same way, which again is a good thing for 99% of what we want to do with language models. But it does limit our ability to ask and answer those kinds of questions with a language model. Um, I don't I don't know the answer. I think you ask a really important question at the end, and I don't know the answer of at what point do we think what the language model is producing is more authentic than what we can get from real humans, and that's a challenging question. That yeah, I don't quite know the answer to that one.
Thank you. Mehmet Badınlı is asking, well, first of all, thank you very much for the presentation. It was really enjoyable and thought-provoking. I have a quick methodological question. Apologies if I missed it during the presentation. How exactly did you operationalize the harmful and negative categories? I'm curious whether you used a specific code book with human coders or relied on an automated classifier, and how you handled edge cases. And related to that, since aligned models are explicitly trained not to produce harmful content, I'm wondering how you think about that large gap we see. Would you frame it as an independent effect of alignment, or is it to some extent a built-in expectation given how those models are trained?
Good. Um, so there's sort of two answers to the classification because we do different things in the different studies. So in the initial study, we sent it out to crowd workers who then rated the responses on the instructions that we gave them, and so that we could compare the human produced versus the LLM produced sets of words texts. In the second study, the one on alignment, we use a large language model to do all of that classification. So we did not go back to crowd workers, although we did have a set of RAs do a small sample of it so that we could look at, agreement intercoder reliability for the language model versus what the human research assistants were doing with those same texts. So that's entirely a language model. I think one of whatever the most state-of-the-art GPT model was at the time, I'm pretty sure is the one we used to do that task. So on some level, we're sort of relying on the language model to do that, but assuming that it's going to do it in a fairly consistent way across text from different sources. Um, so, the rate it is picking up more harmful information in human data in base models and in aligned models or instruction tuned models. Um, we intentionally picked, in regards to sort of your second question here, we intentionally picked models where we could have a base version and an aligned version of exactly that same model. So we have no expectation that's in the pre-training data is different. That should be exactly the same across the different model. The only thing that should really be different from the one set of models to the other is that one has had an application of instruction tuning. And so we're seeing that as the alignment stage that's building in this expectation of not producing harmful output, which is exactly what it's designed to do. And we find that it does exactly what it's trained to do, but it makes it different than how humans would complete that same task.
Thank you very much. The next question is from Sheval Chikuja. Thank you very much. I really enjoyed the talk. It gave me a lot to think about. I wanted to ask that your framework focuses on validation before and during a study, but what happens when an LLM is updated or replaced mid-research? Does the whole validation process need to start over?
Good. This is a great question. It's actually something we tried to be attentive to. I've sort of simplified things in this presentation. In the initial artificial intelligence paper, we actually set out two versions of what this could look like. And one version is you do all of the work with the language model until it gets to the standard you have. And then in the pre-registration, you're saying we're working with this model with these parameters to accomplish this task, which we have already verified meets our standards. And then you run the study. And that's going to be most effective if what you're doing is a relatively discrete task in a short period of time, right? So if it's like we're going to run this study and it will be done in 6 hours, and the end, then like great, that's a good approach. But the other way that we say you can set this up is to pre-register your benchmarks and say we will work with a language model until it gets to whatever the standard of performance is. And as long as we have a language model that is meeting the standard of performance and continues to meet it through the course of the study, then we feel like the language model has been validated and is doing the task that we expect. And we think that's probably more appropriate for something that's sort of like an ongoing long-term task. And so if you're ingesting data and coding it in real time and you're planning this to go over the course of months or years, language models are going to change. And so pre-registering some benchmark and saying what we need is a language model that meets this benchmark. Then if the actual language model changes from time to time, you have some ability to say, it's fine if we switch language models or updated a prompt or something, we have a benchmark and we can show that actually works better, or we're maintaining the same standard even though we're using different models.
Thank you. Rumeysa Türkbey is asking, as someone who studies how LLMs can be used to improve research, I'm curious about your perspective. Traditionally, doing, excuse me, each stage of research ourselves was also how we developed critical skills, such as a feel for the data and intuition for what's anomalous or our tacit knowledge. If LLMs increasingly mediate that contact between the researcher and the material, do you see that as a loss or just a transformation of the researcher's role?
Yeah. In terms of questions that keep me up at night, you have found the one. I worry a lot about losing contact with our research. And if we can produce things that look like good research at scale, I don't know that we have the capability of evaluating and validating at the same scale that language models can produce all of that. Precisely because of exactly what you're describing. Like we need researchers who have an understanding, an intuition, understanding of what is interesting, what is important, what's valuable in the research process, what does that data look like? And I think the more distance we get from that, the harder it is to know what we have learned and gained from the research that's produced increasingly or entirely by language models. But we also just don't have yet, I don't think, the capacity to evaluate that output at the same scale that we have the capacity to produce it. And I think that's a challenge. And I think it's a real challenge for training new researchers for undergraduate and graduate education in particular, and how we use these tools productively, but don't undermine the development of these critical skills. And yep, I think those are really important questions for us to keep asking and talking about.
Thank you. We have two questions left. Emre, thanking you very much for the great presentation. It was truly informative and enjoyable. My question is, your alignment results seem to show the damage is concentrated at the pattern correspondence level. Aligned models still pass the Turing bar. They just carry the wrong opinion distribution. Is this fickleness specifically a pattern level failure that surface validation can see? And if so, doesn't that mean the most commonly run validation, face plausibility, is exactly the one that can't catch the problem you're documenting?
Um, So I'm going to give a yes and no answer. And sort of starting with the no side, some of this was actually very clear on face value. Um, and I didn't show these results, but in the paper we talk about refusals and moralizing. And so the language models, the aligned language models would refuse to answer the question. And there it's pretty clear it's a language model because they say, I'm a language model and I won't answer this question. And they will also do moralizing. So they will, in addition to, I'm not going to answer that question, you're a bad person for asking this question. You should really think about it in a different way, right? So there are some of these things that actually it's very clear that a language model, that's a language model in the output because it's really not responding like a human. So I didn't show those results, but there is some of that in terms of pattern correspondence. On the other hand, I think you're right. And this is part of the argument that's made by um, uh, by some of the folks who have done this. Uh, Jim Bisbee, especially in his paper, sort of makes the argument that we really need to be paying attention to variance in the model. And so just the fact that it produces something that looks kind of human-like is not enough to say, like, is it replicating the full variance and the full range of human attitudes? And this is where it depends so much on the complexity of the task. And we really have to think carefully about our validation criteria because I think just percent agreement is not actually the right metric for a lot of the things that we really care about. And especially, I've wrestled with this in terms of like language model text or conversation. Every word of that conversation might actually be different than another one, but what's the core thing that we care about replicating? And can we quantify or understand that core quality or component? And so it's really hard. And I think language models can and should push us as a research community to develop better metrics and better quantitative methods for understanding and evaluating them.
Thank you. This is the last question coming from Salihan Gökçe. Again, thank you very much for the presentation. You showed that major platforms like Qualtrics are now selling AI personas to replace human respondents under slogans like research without users. I wonder, given your empirical data on how alignment flattens extreme opinions, do you think these commercial tools are risking the validity of market and social research, or is there a specific domain where synthetic users are actually useful?
I think both of those things are true. Right? I think there certainly are risks to commercial tools, and I am not enough in the details of any of those tools, although I know there are some really great scholars behind a few of them. But there are certainly risks, and I would hope they are attentive to those risks, that we are missing big segments of the population or maybe small segments of the population. What are we doing with minority opinions? How do they continue to be represented or unrepresented in language models? What are we doing with opinions that are negative or we don't like? And so I hope these companies and entities are attentive to that, but I think that is a real risk. And so using them, you should certainly be asking a lot of questions about that before trying to deploy things with those companies. But I also think the domain matters. And so I can imagine lots of market research applications that are just a lot less sensitive and it's a lot easier to sort of understand general market trends. Um, and that may be sufficient for the kind of work that many researchers, particularly, private industry researchers need. I think there are other domains where synthetic uses are going to be a lot harder. And sensitive topics are the kind of detail and explanatory information that we need in order to do good social science research. It's not clear those are the same metrics that these private corporations are trying to uh, maximize.
Thank you so much. I think with that, we can close the session. Thank you so very much again for this really thought-provoking presentation. And I also thank our audience for their engagement with the talk and the question and answer session. With that, I'll pause recording before I forget.